Welcome to my channel. In this video I will show you the secrets to a perfect landing and in any aircraft. Here when I say any aircraft is those small aircrafts because in commercial aircrafts it's slightly similar but maybe there are more variations. So let's now speak about these type of aircrafts. Now, in this, I will not try to show you a great landing and say this is how you do it. We will do more intelligence. We will reverse engineer how an autopilot lands this type of aircrafts, and then we will execute it in a similar way and find some key learnings that we can use in this aircraft and additional aircrafts as well. Great. Now let's get started. As you can see here, this is an amazing aircraft. I think the Bonanza, this one I selected. Now from Black Square, and it's a very, very beautifully simulated aircraft. Now, what we will use in this procedure is we will depend, as we mentioned, on the autopilot to reverse engineer and pay specific attention to the following. This is what's called the rudder trim. So this is what changes the nose up, nose down. Now I have here a key on my joystick that I use to fly the aircraft. So when I move it up, I can trim the aircraft nose up, and then when I move it down, I trim it nose down. And even, of course, you can do it using here this mouse. So of course for takeoff now we will use it 0. Now monitor how the autopilot, when it is on engaged, how it controls. Very important. The most important element is how it manages and controls the elevation trim manually or automatically, of course, as an autopilot. Now what we need to put the specific attention, of course, is on the elevation. So this is our elevation, and we will go straight. We are now in Dubai International Airport. We will go straight to a point, turn and come back and land. Now this approach for landing, according to the chart, it should start at 2,000 feet. So always, I think you can take it as a rule of thumb. Anytime you want to come and land, you have to be at the right point. And this is called the arrival point, at the right point, at the right elevation. And that elevation can be 2,000 feet from the elevation of the airport, of course. Now, there is here in this aircraft a very intelligent system. This is the same system equipped with the commercial expensive large aircraft that you use for commercial purposes. This is what's called the radar altitude. So we just keep an eye on it because it's very nice to see. How does this work? This is a very good backup. This one that is in the bottom of the aircraft, a sensor, a radar, that transmits two signals on different phases, and then the reflection back is used by the aircraft to monitor its altitude. Now this is an amazing backup for this, because this works based on the pressure in the air coming through the aircraft. This is to monitor, in fact, the speed, which is this one. So I mean, this one is based on the density of the air. So the higher you go, the density of the air will drop, and this is how you calculate the altitude. And there are adjustments based on regulations, etc. But this is basically how this works. So this works based on the density of the air. But this one based on kind of a measurement between the aircraft and this is why this one works maximum 2,500 feet. And all, of course, commercial aircrafts equipped with this system in here. These two, they should work and they should give you the same reading. This is why if you are coming to land and you find a variation, these two, you decide to do a workaround to know which one is right. All right, now this one is our vertical speed. This is the very, very important element in landing. This tells us how much our speed. So if it is a positive variation, this means we are climbing. And if this goes below 0, this means we are descending, we are losing speed. So normally an aircraft, when it is climbing, if you want to climb fast, it climbs 500 or 1,000, even up to 2,000 feet per minute. And if it wants to come and descend, there is a secret number in here. The best or the perfect descents are those that are based on an inclination angle of 3 degrees. And an inclination angle of 3 degrees, if you are around 6 nautical miles from the airport, there will be around, just remember it, 6 feet down. So we descend with a rate of 600 feet per minute. So this means every 1 minute we go down 600 feet. So if we start from 2000, as you can imagine, every minute we lose 600 feet. So this means within 3 minutes plus, we are supposed to be touching ground and land. All right. This is our very important airspeed. So now we are on the ground and our speed is 0. Now, when we are flying, of course, pay those special attention for those who are very new. An aircraft like this one, it will stall around this area here. So we don't want our speed to drop below 80 knots. Once it drops below 80 knots and we are in the air, we face the risk of stalling. Stalling means like the aircraft does not generate enough lift to stay in the air and it will fall and crash on the ground, of course. So this is why we need to monitor the airspeed, and when we land and touch the ground, we're supposed to be around 80 knots, not lower. Not recommended to be lower, even though with the flaps we can go lower, but we will touch the ground around 80. 80 is a good speed. Right, so now, as we said, what we will do, and this will be an amazing exercise, hopefully you will like it, we will take off and engage the autopilot to come back and land the aircraft. After that, we will monitor and analyze what the autopilot is doing and learn from it. And this is what our intelligence is, right? And then later, after that, we will take off again, go and repeat it manually. All right, and very important, we will see how when we steal the approach and the strategy from the autopilot, hopefully we can have a very similar, perfect landing approach. Great. Now, this one is an indication meter, and also it can give us here, as I will show you here, 2 bars that tell us the what we call the gliding slope from the autopilot. Now, somebody might say, oh wow, you're using a lot of instruments to help you guide, and this is the idea behind an approach in aviation. It's called here IFR, which is Instrument Flying Rules. So if you want to fly using the instruments, you must use the instruments. You cannot just look out of the glass and fly the aircraft completely visual. If you want to do that, there is another approach for aviation called VFR, where you don't normally buy an aircraft with complex instruments. You just buy a very simple aircraft, and when you fly, you take a permission from ATC to fly VFR. But again, even in VFR flying, they use some technology, because of course you need to depend on some instruments to guide you, at least see your elevation, right? Your altitude from the ground. So you cannot fly completely blind, any aircraft. So again, VFR is depending on visual, IFR is depending on instruments, and in depending on instruments, we must use the instruments and the maximum capabilities of the aircraft. However, why do we need to land an aircraft manually? Because of course, in many scenarios, if there are so many variations and variables, we may not be able to depend on the autopilot to land the aircraft completely manual. I need to have a very control ourselves. Now, without talking too much more, let's go ahead and take off. And before I do that, I will set the flight procedure for. So this is from Dubai International Airport, and then the procedure, very simple. I will just select an approach, which is this runway is 30R, and when we come back, it will be 12L. We will use ILS, and this will be the point here, this will be the point in the sky, which is called the transition point, where from this point, the landing officially begins. Great, so activate. Okay, and go back and open the map. And now this will be easy. Let's take off and let the autopilot do the work. Before we do that, let's set up this to 2,000 feet, because we need to have this as 2,000 feet. All right, now this is the mixture maximum. This is the RPM of the propeller is maximum, and we're gonna just control the throttle. Great. So let's increase the volume slightly. Nice. This is the throttle, and this is the RPM of the engine. You want to see some nice graphics. So now, of course, I cannot see the speed, so I will depend on my feelings to take off. Which we normally don't do in, or they don't do in aviation. Let's take the flaps up, we don't need them. And yeah, now I think let's get back into the cockpit so that we don't crash while anyway we are playing, but not crash while we are playing. So now let's engage the autopilot, and let's engage also the altitude. We set a vertical speed and arm it. So now the aircraft will climb to 2,000 feet, and two small things I will do. I will set the RPM to 2,500 to reduce the pressure a little bit from the engine, and reduce the throttle to 2,500. This will reduce the speed a little bit and make it stable. So now I've selected the autopilot, but I did not tell it to use navigation mode. Let me show you the map here properly. Reduce this so that you can see better. So let me select in the autopilot something called navigation mode. When I select it, the aircraft now, even I think we were perfect. You notice it turned slightly right to align with this. So now what we are doing, we will go straight to this point, which is the approach point, turn, and then we will let the autopilot come and land the aircraft. This frequency came in the standby automatically because this is the frequency used by Dubai International Airport, 12L, ILS, which is the runway 12L. It has an antenna at the end of it that transmits on this signal, so we have to just activate it. So let's activate it. Once we activate it, we start to receive on our indicator the location information from this, and also we receive the distance from the airport. So notice now we are going away because of course we did not turn back to land. Okay, the autopilot is doing a great job. You notice here now this trim, as you can see, the autopilot is maintaining it. So now I'm just doing nothing, and you see those because of turbulence a little bit in the air, the autopilot is moving a little bit forward, backward, the joystick, the virtual one of course, to maintain perfectly leveled speed. So now our vertical speed is 0 because we are flying constant altitude, which is 2,000 feet. And this is the second radar, which is showing also 2,000 feet, which is amazing. This knob here you can enable it so that when you are coming to land, if you come to a certain altitude, here where you decide whether to continue landing or you execute something called missed approach. So we'll see if we can do another video about how, if we cannot land, how do we execute the missed approach. Great. Now we are coming close to our arrival point, which is this one. So we'll go straight and then turn and then come back. Once we come back here, we will activate the autopilot approach mode, which is this one. And we will talk about the exact step-by-step we learn from the autopilot on how to land the aircraft. But for the time being now, you notice we are having the following settings. We have 2,500 in terms of the main, like the throttle pressure, and the RPM is also 2,500. So pay attention to those two because these are the power. Now, this will not, once we are into landing, we will set it to the maximum in order to have the reserve RPM in case we need to immediately take off instead of land. So we will only adjust the power from the throttle. Okay, and pay attention to this, right? Now the frequency here is activated. Okay, why this is not active in landing mode? Because we did not activate the, as we mentioned, the landing or the approach mode. So pay attention now how the autopilot is like maintaining perfectly zero or near zero. Now if I reduce power a little bit, so because of course this depends based on how much power I am putting into the engine, into the to power the aircraft. This is why the autopilot manages this trim, just how much lift is required, and the rest of the energy goes into the speed. Great, let's have a quick look outside. So Dubai International Airport is behind us. I think we can see the runway, the one to the left. So while we are turning, let's talk a little bit about what we need to manage. Yeah, now we are turning, which is great. So now the secrets for a perfect landing are the following. You need to fix as many variables as you can. What are the variables? So the first important variable is power, because one common mistake is the following, which is a crazy kind of landing where you are landing, you find yourself descending too fast, and then you pull it back, the plane up, and then you start now to, because you descended too much, now you start to climb back, and then you find yourself, your speed is low, is getting very low, so you increase power. You increase power, and then you find yourself, instead of descending, ascending again. So this creative mess leads you to one thing, either a crazy landing or a crash. Okay, or you simply cannot land. So now I'm going to show you step by step on how you can control those variables by minimizing the changes of so many instruments. So we will try to land without changing the throttle too much. Sorry. So we set the throttle, and then we do specific things and watch them carefully. Now, how far are we from the airport now? We are 14.4 nautical mile. Now, you notice the actual approach for landing starts around 6 nautical mile. So 6 nautical mile is like secret, 6 here, and also 600, descending of 600 feet per minute. Okay, so remember this one now. So you notice now we are getting aligned with the runway, and now let's activate the approach mode. And once we activate the approach mode, we need to make sure we are not using GPS, but the localizer of the airport. Now you notice once I did that, and the aircraft can now sense, there are two antennas in the aircraft, they can sense the antenna from the airport. We got those 2 points here, look. Now what does this tell us? We are slightly lower than the gliding slope. So these are higher, this means we are lower. But this is not a problem because we are not descending. Give it a little bit of time and this will come to us. The perfect descent angle for landing is 3 degrees. And based on those configurations, a descent of 600 feet per minute should give us a perfect landing. Now, you notice here, the navigation system is telling us about the next milestone. So next milestone where we will really begin the descent is gonna happen after 3 nautical miles. So now we will fly constant speed. The autopilot is flying constant elevation. Once it comes to this point, it will start to descend. Now what we will do, once we start to descend, our speed will start to increase, which is a problem. So let's start from the following now to prepare for landing. Okay, now the RPM set at maximum. You say, oh, this is maximum power, yeah. And then lower this throttle to around 17 here, like, okay. Of course, before the landing gear is down, if you lower it before here, the aircraft will complain. Will tell you, oh, we are crashing. So now we are losing energy. And as you can see, our speed is quite high still, like 155 or 150 nautical miles per hour. And we need to land on 80. Okay, now look, we started to descend. Immediately when we start to descend, we put down the landing gear. This is to counter, because the landing gear will create resistance in the air, and it will counter the extra energy we get while descending. Okay, so you notice we were 6 nautical miles from the airport, and now we are descending at, the aircraft is 600 to 700, so it varies it so that we can maintain this perfect gliding slope. We are still losing speed. Why? Because of this. The landing gear that you can see now. All right. Now let's do one more thing. We came into this area, which is, we can open the flaps. Now, at this moment, once we are around 1,000 height and around the 3, which is like half the distance that we want to land, what do we need to do? Lower again the power to, you can even go slightly, it depends on the speed, because don't forget, we will repeat this manually. So now you notice, look here down, if you are watching down, what the autopilot is doing is raising the nose up. So now the nose is going higher. And once we do that, we are losing energy. So the idea is the aircraft has a lot of energy, kinetic energy, and while descending, we gain more energy in terms of speed, and we have to consume and take all of that energy to land the aircraft. So
500.
Okay, so now we are 500 feet from the ground, and our speed is slightly higher. Did we lower the flaps? No, so let's lower them now. And this will create additional drag, and it will help the aircraft to fly as well slower without getting into the stalling. So yeah, we are good now, because I think we need to land on this, not in here. Okay, so this is in fact the starting point. This is not allowed to land in here, so we have to land in this area. Okay, so we are still perfectly. Now we do something, we cut completely the power, and we put the aircraft in what we call a flare. Yeah, good. Disconnect the autopilot. Yeah, so this was the landing from the autopilot. Now what do we need to do? Sorry. Do the landing ourselves. Let's increase the throttle. And take off. We call this touch and go. Now we are taking off. Okay, now I'm gonna adjust the trim to around 0. And normally when you are climbing like this, because now I need to make a turn, right? You don't do a turn before your elevation is around 500 feet minimum. And you notice I'm climbing now around 1,500 feet per minute. And now we're around 1,000. It's safe because there are some buildings, you notice. And while I am turning, I'm keeping climbing. So always watch carefully when you are turning. So if you see this one here, you need to turn, which is this one, it's 5 degrees. This means a complete 360 turn in an aircraft should take you 2 minutes. So don't hurry up when you're turning, like you want to do it immediately fast. I will go back here and activate again the procedure. Okay. And and this time is going to be manual. Yeah, this is back. Okay, so let's align now with the runway. Now I will reduce slightly to 2,500. You remember those? And also the RPM. Running the engine higher than 2,500 RPM, and the throttle will create extra heat. And now I will try to trim the aircraft to go straight. And look here at this down. Yeah. Okay, so I will leave the joystick, and then I will take the nose up so that the aircraft will continue to go straight and level on its own. Now there is, because there is some weather here, there is some air, I think, coming from my right side that's turning the aircraft to the left. So this is why I have to compensate that. I don't want to do horizontal trimming now, just let the aircraft, but you can do this if you have a light. But normally you depend on the autopilot when you are doing long flights, of course. No one today keeps like driving a car. Even cars, of course, they have autopilot or cruise control, what used to be. It's an old technology now compared to an autopilot system from a new cars, electrical, like Tesla or others. All right, so now our elevation, you notice, will increase the nose up slightly to climb. And we're gonna go straight to the same point. Now, instead of me, notice what I'm doing. I will keep holding the joystick slightly to the right as a kind of a trim, and notice now how the aircraft is completely stable. And this is what normally. This is why I even can trim it, but I don't want to do this. Yeah, we're losing altitude. Let's increase the trim slightly. You notice I did not put GPS. I kept it on the localizer because anyway I will use the localizer for landing. So it's already the localizer active. However, the autopilot is off. And as you can see, the gliding slope is showing on the HSI unit, and it's telling me I'm above the gliding slope, of course, because I'm going in the opposite direction and I'm not landing. So I will increase even my elevation to 2000 to make sure when I arrive to that point I start with the same position when I use the autopilot for landing. Yeah, aircraft is stable. Our speed is not that high, it seems, because now there is some air, maybe it depends on the flow of air. If I want, I can increase it, put more throttle or slightly more RPM. But if you are in the landing mood, you know, coming to land, you know, the more you lose the speed, the better. It will be easier. However, you have to come with the same configuration. So if you come with a very low speed, now all what I was talking about does not work, because you will lose the energy very fast, and then you need to put the throttle more. So this is why the good approach for a good landing is to come with your cruising speed, which is here like around 140, 150. Okay, so this is why I put now more energy to try to gain speed. So that when I come to land, I will have a similar configuration to the previous one. Yeah, I'm trying to keep it down so that you can see the trim. Okay, so yeah, we are very close to our point where we turn. Let's look outside. Oh, it's crazy. So sorry, you notice something? Why we were not unable to gain speed? Because the gear was still down. Yeah, because the gear creates a lot of drag. Okay, and also the flaps. So this is my mistake. So anyway, then this is a good learning that after you take off and your elevation is above 1000 feet, just take up the flaps and take up the landing gear. I was wondering why I'm not being able to gain speed. Is because of course I have drag from both the flaps and you notice how our elevation started to go up. You now need to trim again the aircraft to around 0 to really balance it. Okay, so this is very good learning that you know, the configuration of the aircraft is very key. And now descending to go back to 2000 feet. And while doing that, you notice how I'm gaining a lot of speed. And that's why I will reduce back the RPM to 2500 and the engine to 25. But now I think now we are happy because we are, you know, and you can easily gain speed now because you have a lot of power. So this is why normally an aircraft with its cruise power, elevation trim 0, you should go straight. Okay, don't want to go very high. All right, so here where I turn, one important assumption for a perfect landing is, which is they say the good landing starts with good approach, you know. So this is why you need to go to the right point to give yourself enough time to configure the aircraft for landing. So now while turning, yeah, so this is when your phone rings while you are coming to land. So I'm trying to drop my speed, sorry, my elevation, and now let me do the turn. I'm trying to turn. You notice here there is a red, so you're not supposed to turn too fast. And why? Because you also lose elevation fast. Okay, we're coming close to align with the runway, which is 12. This means 120 degrees on the magnetic compass. Now, good. So now we are parallel to the runway. So we settle and we do an assessment. So we need to go slightly to the left, right? You notice we are to the right. And you see this bar here? This bar is saying we are to the right of the runway. Now, the moment I come in here, I will reduce the RPM because I have a lot of energy, and try to maintain my... So you see now the time between now until I am 6 nautical miles from the airport, I'm stabilizing the aircraft. Stabilizing the aircraft, which means I'm 2,000 feet and perfectly aligned with the runway. And my speed is manageable and everything is ready for me to start the landing. And this is important to give ourselves enough time. So you can see on this bar that I am below the gliding slope. Why? Yeah, because I am away. And this is why I will not descend now. I will keep my altitude the same. In aviation, there is a big difference between altitude, height, and level. So we will talk about those in a different video. So if I use them, they don't have the same meaning. You notice now the bar is coming. So this is why I need to come back here to, otherwise I will cross to the other side. Now you see I'm kind of perfectly aligned with the runway. Slightly to the left, but it's not important because during now my course to land, I will... so now let me now focus on my elevation. So notice now I still did not drop the landing gear or the flaps because I'm not descending now. I do that when I start to descend. I will focus now on trimming the aircraft slightly more up so that I maintain this 2,000 feet. And I am now 2.5 nautical miles, you see on the GPS, from the actual beginning of the gliding slope. I will try during this time to align myself back with the runway. This is why you see those pilots, they keep moving the joystick left, right, so that they stay because the aircraft deviates very fast from the line of sight with the airport. Well, I'm 1 nautical mile now from the airport. I'm sorry, not from the airport, from the starting of the landing. And how do I know that? Okay, I will see myself on the gliding slope. Once I aligned with the gliding slope, okay, so now I am well aligned, and you can see now how the 2 dots starting to go down. And now immediately, because if I continue without lowering my altitude, I will become now, so I will lower immediately what? And now I monitor my altitude with regards to the gliding slope. So I need to maintain the gliding slope. I always prefer to be slightly higher, not lower. Higher is safer because I have a very long runway, right? But if you are lower, you get into the risk of hitting those buildings, which is, okay? And now I lower more the power to 15 or even more because I have high speed. But not too much low, huh? Because we don't want to, and I keep, of course, myself aligned with the runway. Did I lower my flaps? Not yet. I can do this anytime, but I will not do it now. Why? Because I'm doing well, you know. I don't want to create so many additional variables. I'm already losing speed and I'm maintaining my gliding slope. I keep a little bit always higher, but I focus on aligning my aircraft with the runway. So now I'm slightly drifted to the left. I go back. Important, monitor how my vertical speed is near constant. So I'm gliding down at 600 to 700 feet per minute, exactly like the autopilot did. There's something called rudder trim, which is those that you use in your feet. Now, when you are above the runway, if you need to do those very small correction to put the aircraft completely straight on the runway, this is what they do, especially if there is a lot of you know, wind. We can do that as well. But now you notice how we are like, great, we are perfectly aligned with the runway. Now I put down more one level of flap to take more of the energy. Lowering slope, slightly more power to lose more energy. And my gliding slope is okay, is good. And take the nose slightly up to keep without touching down because my speed is still high. So doing that will consume, and now I flare completely. I take all the energy. And now I am 80 degrees. And this is a good landing. So I hope you enjoyed this video. Now you've got an idea about how an aircraft lands. It's amazing, the simulation. When you press brake, you look how the energy, the shock absorbers go down. Great. So let's quickly take this exit. There is a rule of thumb: when you land, you have to evacuate the runway. Look here, an aircraft is taking off. It's always busy airport, Dubai. And this is so nice. So yeah, can I beep beep please? Okay, so let's end the no, we will not end the aircraft in here. So this aircraft is just waiting. We have the right to... What right? I mean, we are intruders in the airport. It's a nice hobby because it stimulates the mind, and the amount of science, engineering, and physics in this hobby is really amazing. So this is why it's a nice hobby for anybody who wants to explore the world from home, and enjoy learning something new. Again, thank you for watching this video, and I hope to see you in the future videos. I'll come here and stop. Next to this Emirates aircraft. We are below the wing. Okay. Brake. Turn off the engine. All right, so see you. Flaps up.